Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called A New Toy by Sandra and Nala, and here are the rules. Nala is at a lake looking for a new toy. Sometimes she gets lucky and other dogs or dog owners leave their toys somewhere. Whenever she finds one of those, it's like birthday and Christmas combined. Will she get lucky today? The grid is partially covered in fog. Entering correct digits will clear the fog from surrounding cells, possibly revealing more clues. So this is typical fog of war, where if you place a correct digit in a cell, you will clear the fog in that cell and in the 3x3 box centered on that cell. And it might reveal more clues. We have normal Nurikabe rules apply for every box except box 5, which is neither ice nor a safe path. It's a lake, I am assuming. Okay, so what exactly are ice and a safe path? That's where the Nurikabe comes into play. We have normal Nurikabe rules except for box 5. So everything that I'm going to say about these next rules don't apply to box 5. We need to shade some cells, which is the safe path, such that all shaded cells are orthogonally connected and no 2x2 is entirely shaded. So that is the safe path, and I assume the rest is ice. Yes. So we have some sort of path that we go along, which, I guess we'll make it green. We'll make the path green. Even though I usually have shaded as blue. But because in this case, the path is, well, we have ice, right? So ice sort of more translates with blue than anything. But, so all shaded cells, which are green in this instance, must be orthogonally connected. And what does it mean to be orthogonally connected? That means you must be able to go from any cell in the shaded region to any other cell in the shaded region just by going through edges, all while staying within the region. So this is an example of a valid shading here, because you can go from any cell in the shaded region to any other cell in the shaded region just by going through edges, all while staying within the region. This would not be valid because, again, to get from this cell to any other cell in the region, you could not go just through edges while staying within the region. You would have to go through a corner, or you would have to go through an edge and exit the region, which is not allowed. Also, this is not a valid path because we have a 2x2 area that is entirely shaded, and that is not allowed either. Every contiguous set of unshaded cells is ice. Each ice area has to contain exactly one circled cell. And these are the circled cells here as examples. And the circle digit indicates the size of that ice area. Iced areas cannot touch each other orthogonally, but may do so diagonally. Additionally, every iced area contains each number from 1 to its size, which is the circle digit exactly once. Okay. So I guess are all the circled cells necessarily ice? I don't know. It looks like it. It looks like the circled digits must be iced areas, because it doesn't say otherwise. But anyways, so this is part of an ice area, which is an orthogonally connected area, which has 7 digits in it. So it could be something like this is an iced area, and like this is, well, obviously it's going to be problematic because this is probably an iced area too. But basically the path would essentially block this iced area into a specific region. But say this was the this would be a patch of ice, right? And again, it's the contiguous area of it. And it would have to have the digits 1 to its size exactly once in this contiguous set of unshaded cells, right? So it would have to have 1 through 7, essentially, in this shaded region. Assuming that this was the region here, right? Okay, so this is basically the Nurikabe, but remember, it does not apply to box 5. So there is no ice or path, safe path, in box 5. It's just the lake. Okay. We also have normal Sudoku rules apply, which is place the digits 1 through 9 in every row, column, and 3x3 box exactly once each. Nala is curiously searching the safe path for exciting things. Digits on an arrow sum to the digit in that arrow's circle. No 2 arrows overlap. So all cells containing an arrow are always on the safe path and never on ice. So this looks like an arrow here. So this must be, these 2 digits add up to whatever this digit is. So say this was like a 2 and a 5, or you can't have 2 and 5. Say this was 2 and 6, then this would have to be an 8 here, because the 2 and the 6 on the arrow must sum up to the digit that's in the arrow's circle. And anything that's on an arrow is always on the safe path and never on ice. So that's why we do have this colored as safe path. But I think the 3 in the circle can only be in ice. So we have to keep that in mind. Digits in cells that are connected by a white dot are consecutive. Digits in cells that are connected by a black dot are in a 1:2 ratio. Not all possible dots are given. So actually, let's say this was 6 and this was 2. If this was 2, this would have to be 1 or 4 to maintain the 1:2 ratio. And they say that there is no negative constraint, which is similar to basically not all possible dots are necessarily given. But if this were a 2, this would have to be 1 or 4 to maintain the 1:2 ratio bits between them. And say we have this blue X marks essentially what a white dot would be. So say we did have a white dot here. Then if this were, say, 6, this would have to be 5 or 7 to be consecutive with the 6 if there were a white dot between them. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay. So, everything on an arrow would be on the safe path. Or it's all cells containing an arrow. So this does not necessarily include the circle, but we have Nala here in the circle, so that has to be part of the safe path. This is the safe path, this is ice, and it's 3 in size. So therefore, this must be safe path. This must be safe path for this to connect because it has to orthogonally connect. This then must go this way. This is blue. So this is size, it has to be 3, and this must be 1 and 2. So this has to be 1, 2, 3, because all ice patches must contain the digits 1 through its size in exactly once in the area. So since this is 1 and 2, what can this be at minimum? It's 4 and 5, which add up to 9. So therefore, this is 9. This has to be 4 because 5 can never be next to a black crop key dot, because if you have 5, you get 2.5. If you double 5, you get 10, neither of which are digits. So this must be 4, and this must be 5 here. This is along the path, then. But we have a 2x2 area that has 3 shaded cells, which means this cannot be shaded, so this is unshaded. It then must go this way. So this has to be 6 or 8 here. And this is 6 or 8 remaining. 2 eliminates 2 here. So this is 1, and that's 2. If we have, okay, 4 is in a 1 to 2 ratio with 2 or 8. If we included this one here, these would be in the same unshaded region. But each ice area has exactly 1, so this cannot be blue. This has to be green. So it's probably the end. This is blue here. This must be blue here, and it must be 7 in size. So this has to go blue that way. Green goes to here, green goes to here. This can't be green because we have 3 greens in the 2x2 box there, so green has to go that way. Blue has to go out this way. This is the digits 1 through 7 in this ice area. So this cannot be 8, it's 2. Therefore, if this is 6, this must be 1 and 5, adding up to 6. If this is 8, it cannot have... It could be either... It can't be 2, 6. It could be 1, 7 here. But we can't have 3 and 5 here because of the 3, 5 in the row. So this is guaranteed to be 1. So that's 1. This is 9. These digits must be... so this could go curl back that way. This one either goes that way or goes that way. And either way, this cannot be 1 or 2. It's 3, 4, 5, or 6 remaining then. This is 1, 3, 4, 5, 6. This is 2. It must be 2 in size, and it cannot include the 1. It has to have a 1 to add up to 2. So it cannot be 1 and 2 there. Therefore, this must be blue and is 1, which means these must be green. Because these two have to be green because the path has to orthogonally connect. These have to be green because this is a size 2 ice field, which means it cannot be touching another ice, which means these are not ice. And these must orthogonally connect, so it must orthogonally connect that way. That means that it orthogonally connects through here. This is a 2x2 that has 3 shaded, so this is unshaded. This cannot go to here as a green because it must go out this way. And if it enters here, it can't exit back out, so this is blue. Okay. Remaining digits here are 3 through 8. And they still could be 3 through 8. This can't be 3, 4, 5, though. Remaining digits in row 2 are 6, 7, 8, 9. We don't know where this arrow goes. We can't see it. remaining digits in row 3, we have 1, 2, 3, 4, 5, 6, and 8. And 2 is guaranteed to be one of these two. Hmm. Remaining digits of row 1, we have 3 through 8 here. 1 and 2 in column 3 have to both be in these cells. We're not sure which. If this is 1 and 5, this has to be 6, which makes that 8, but then this would be 3, 4, and 6, which eliminates 6 in the rest of the row. If this is 1 and 7, this is 8, which forces that to be 6, which eliminates 6 in the rest of the row. So this can't be 6. We also know, so again, 1, 5 makes that 6, makes that 3, 4, and 6, which eliminates 3 and 4 in the rest of the row, and 3 and 4 in the box. 1, 7, 8 makes this 6, which makes this 3, 4, and 5. Okay. So then what are the possible combinations again? We have 1, 5, that's 6. This is 8. So this is 3, 4, 6 here. This is 5, so this is 7, 8 as a pair. If this is 1, 7, this is 8. That's 6. This must be 3, 4, 5. 1, 7 means that's 8. So this can't be 8. It would be 6 here, and then this would be 8. So 3 and 4 can never be here because we're guaranteed 3 and 4 here. It's either 3, 4, 6 with this being 5 or 3, 4, 5 with this being 6. This is size 9. So it has to be blue that way. Green has to continue that way. Blue has to go out this way because it's size 9. So this cannot have a 9 here. The green has to go out this way to orthogonally connect. We have 1, 2, 3, 4, 5, 6, 7, 8. This is 1, 2, 3, 4, 5, 6, 7. And that's done. So this must be green as a region. It must orthogonally connect that way. We have 1, 2, 3, 4, 5, 6, 7, 8. This is 9. That doesn't work. 1, 2, 3, 4. So 1, 2, 3, 4, 5, 6, 7. This must be green. But then the problem is this is 1, 2, 3, 4, 5, 6, 7, 8. And then that's 9. But then it has to orthogonally connect to there. Oh, it doesn't go here. It goes here. It doesn't have to go this way. No, it's 2 by 2. It's 2 by 2, which means it does have to be blue. Huh. I'm running into problems here. This 9 here means this has to be green and green, right? But the problem is it would have to go back here, and then this 2 by 2 area would be all green. Huh. That's a problem. Huh. That's pretty bad. 1, 2, 3, 4, 5, 6, 7. Cannot. Ah, okay. We have, yeah, this is a major issue. 6, 7, 8, 9. This has to be size 3, so this has to be green, which is why it's green, 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 right? This is size 2, so it goes there, which is 1 and 2. This has to be green because otherwise this would be one block of ice, which is never going to be size 7 and size 2. This is size 7. This must be 1, 5, or 6 there. We're guaranteed one of them's 1. We are guaranteed 3 or 4 there. Yeah, I don't know. This can't be 1 because of 1 in the row. So 1, 4, this ice region must be here. So that's 1. Which means 1 cannot be here. This is a sum of 2 digits, which means this must be 2, 6, adding up to 8. So we have 2, 6, adding up to 8, which means this can't be 8 here. There's no 6 or 8 here. This can't be 9 because it's in the ice region, so 9 has to be here. This is 9, that's 7. So no 6 or 7 here. No 2 here. 6 eliminates 6 here, so this is 5. Which means... So how does this work? Oh, I guess she doesn't have to continue on from there. Oh. Okay. So this actually doesn't... Yeah. I guess she can... Yeah, she doesn't have to go... She doesn't have to continue on this... The save path is basically not a... Huh. Normally when we say path in Sudoku, we imply that it has to be... It has to be one long line, essentially. But it doesn't have to in this case. She can go... Nala can go here and then double back and then go here. Which I guess is what she has to do. So then this, she goes along this. This is blue. Because this 2x2 area can't be all green. Because like we said. So Nala just basically goes here. Which makes sense. This is how a dog normally reacts. Is curious about something here. Goes back and then goes back along the safe path. And this is 9 in a size. That means this is a safe path here. Every ice area has a circled cell, one circled cell in it. And this can't be 1 as a circled cell, so blue has to go that way. Yeah, so we don't actually have any information here. We just know that these are safe path. And because these cannot, this is done as an ice region. This is safe path for a similar thing. And this must orthogonally connect. So this has to extend out that way. But that's all we have. Yeah, so I didn't use any other thing about safe path. We already had that as a 9 circled, so therefore this must be all ice. This is in a 1 to 2 ratio, and it cannot contain 2, so it's either 3, 6, or 4, 8 there. 5 is here, which eliminates 5 in the rest of the ice region, so this is 3, 4, 6, which eliminates 3, 4, 6 in the rest of the row. No 6 here, it's 8, no 8 here, it's 5. which means this cannot be 5 here. This is 3, 4, and 8. 3, 4, 6 eliminates 3, 4, and 8 eliminates 8 here. So this is 6, which is 1, 5, adding up to 6. This can't be 6 anymore, it's 7. Remaining digits in this ice region are 1, 2, and 6. Because we already have 3, 4, 5, 7, 8, 9. That eliminates 3 and 6 as a possibility here. So this is 4, 8. Remaining digits in this box, then, this 1, 2 eliminates 1 and 2 here. So this is 6, which eliminates 6 in the rest of the column. Remaining digits in this right central box are 3, 7, and 9. 3 cannot be here because that would be the sum of this digit and another digit, which is at least 4. This can't be 9 because of 9 in the column. Okay. Remaining digits in column 9, we have 3, 4, 8, and 9. This 4, 8 pair eliminates 4 and 8 in the rest of the column, so this can't be 4 or 8, it's 3, which means this can't be 3 here. No 3 here. 3 eliminates 3 here, so that's 7, which makes this 9. This is size 3. So we have 4 and 5, or 8 and 1 here to be the sum. Well, it could be 3 digits, actually. What are the remaining digits in column 8? We have 1, 5, and 6. So this can't be 6 because this is at minimum 4 and 6. So we can remove that. Remaining digits of column 7. We have 2, 4, 8, and 7. And this ice sheet must contain 3, 2, and 1. So this must be 2 here. Which means this can't be 2. This is an ice sheet of size 1. So that means these must be surrounded by green cells. And this must orthogonally connect as a green cell. So this must go ice sheet here. This is surrounded by green cells. So this has to be 1 here. Because this ice sheet must have 1, 2, and 3. So this cannot be 1 or 2. This can't be 1 here. Where's the 1 in column 3? It has to be here. So that's 1. This is 2. 1 cannot be here. So this is 5 with 4 adding up to 9, which makes that 8. This can't be 1 or 5. It's 6. Okay. This 2x2 has 3 shaded regions, so this can't be shaded, or it can't be green, so it's blue. This has to orthogonally connect, so that's green there. This has to be either 3, 4 adding up to 7, which it can't be because we have a 7 in the column, or 3, 6 adding up to 9, which it has to be. So we have 3, 6 here, and this is 9. This is 9 as a ice sheet. It cannot contain this. Okay, so this is all on the path. This can't be because this is blue. Because we have a 2x2 area that has 3 green in it. Remaining digits in column 3. We have 3, 5, and 8. And this can't be 3, this can't be 8, this can't be 5. That means the remaining digits here in this left central box have to be 4, 6, 7. And this can't be 4 because of 4 in the row. Okay. This eliminates 3 and 9 in the rest of row 7. So the remaining digits in row 7 are 4, 7, 8. There's no 8 here. We don't know about these. These digits are consecutive. 4 can be with either 3 or 5, but this can't be 3 because of a 3, 6 pair in the box. So 4 would be with 5. 7 cannot be with 6, so it would have to be with 8. 8 can be with, but 8 can't be here because of 8 in the column. So that means this can never be 7. So we have a 4-8, 4-8 pair in this lower right-hand box, which eliminates 4, 8 in the rest of the box. This can't be 4 or 8, it's 7. This must go out here because it must be connected to a circle digit. If this is 4, this is 5. If this is 8, this has to be 7. Because it cannot be 9 because of 9 in the column. Since this is blue, green has to orthogonally connect, so it must go this way. This has to have 9 cells in it, so it cannot go around that way, because if it does, this is only 2 cells, so it must go this way. Okay. Remaining digits in this lower central box. We have 2, 4, 5, 7, 8, 9. Obviously no 2, 7 here. No 8, 9 here because of 8, 9 in the column. No 2 here. No 7 here. No 5 here. Where is the 2 in this box? It can't be here because that's consecutive with 4 or 8. Can't be here because of 2 in the column. Can't be here because of 2 in the rows. So 2 has to be here. This doesn't have a circle, so it must connect. It must probably connect with this 9 here. Because you have 1, 2, 3, 4. Yeah, you can't have 9 here without connecting to here, right? This is 8 at most, 9, but then that connects to this. So this is 4 blues. It has to have connect 5-way here. So this is blue there. This is green here. Therefore, all of this must be green. And this must be green. So we have 1, 2 here. 9 cannot be in this ice region. So where is 9? It must be here. So that's 9. Which makes this 3, which makes that 9. We have 1, we have 2, we need 3 available in this ice region, and it cannot be here because of 3 in the row, so 3 has to be there. We have 4, 5, 7, 8 as a quadruplet in this ice region, which eliminates 4, 5, 7, 8 in the rest of the ice region. So this has to be 6. Remaining digits in row 8 are 4, 5, and 8. And remaining digits in row 9 are 4, 5, 7, 8. Okay. So yeah, Nala ran all the way through here, all the way through, or I guess this is just safe path. Yeah, it's a safe, it's like sidewalk. It's a sidewalk or something. Or non-iced sidewalk, I guess. Five cannot be here. So we have a 4, 7, 8 triplet in this ice path. So this cannot be 4, 7, or 8. It's 5, which is consecutive with 4. 5 eliminates 5 here, so it's 4, 8. This can't be 4 or 8. It's 7, which eliminates 7 here, so that's 4. And I guess this is a treat here, or some sort of thing here. 4 eliminates 4 in the rest of the box. So this is 5, 7, 8 as a triplet, which eliminates 5, 7, 8 in the rest of the column. 4 and 6 eliminates 4 and 6 here, so that's 7, which makes this 6, which makes that 4. 4 eliminates 4 here. This can't be 5 or 7, so that makes that 8, which makes this 5, which makes that 7. 4 eliminates 4 here, so it's 8. which makes that 4 and 8. And the rest we figure out from normal Sudoku. We have ones. So 1 has to be one of these two. 2s. 2 has to be one of these two. 3s. Okay, this is probably... this is not the best way of attacking it. Okay, so let's look at the remaining digits in row 4. We have what digits remaining? 3, 4, 8, 9. This can't be 4, 8, or 9, so that makes that 3, which means this can't be 3 here. This can't be 9. This can't be 8. 3 eliminates 3 here, so that's 6, which eliminates 6 in the rest of the row. Remaining digits in column 6, then, are 2 and 7. This can't be 7 because of 7 in the row, so that's 2, that's 7. 2 eliminates 2 here, so it's 1 and 2, which eliminates 1 here, so this is guaranteed to be 1. We have 5 and 8 remaining in row 8, 6, so this is 5 or 8. Remaining digits in row 5 are 3, 5, and 6. This can't be 5 because of 5 in the column. We have a 3, 6 pair in column 4, which eliminates 3 and 6 in the rest of the column. This can't be 3, it's 4, which makes this 3. 3 eliminates 3 here, so it's 8, 5, and 3 there, which means this can't be 8, it's 4 and 9. 3 eliminates 3 here, so it's 6, which makes this 3, which makes that 6. 5 eliminates 5 here, so that's 8, which makes this a 5. The solution is correct. Nala found a shiny new, to her, ball in the bush near the lake. She made the cutest happy dance and then carried it home. She loves when she finds toys on our walks. Yeah, I just got confused about the rules because I'm so used to seeing path and seeing that it has to be like a sort of a snake-like object. But in this case, that there was never declared that, so that was on me for not understanding that. I didn't really use it much. I only used it here, and then I realized that that's actually not the case. But eventually I got around to it anyway, so that's fine. Yeah, I was a little thrown off by this part, but then I realized that I didn't interpret the rules exactly correctly. So, yeah. Yeah, what I can say, yeah, I don't know. I think that what threw me for a loop was the path. But I mean, it's perfectly fine to call it a path because I mean, there's nothing guaranteed about that, about having a path be essentially a snake-like thing, right? So, that was on me. Bad assumption there. Again, I didn't use it, I used it, but it didn't come into play for the puzzle solving, so... Interesting. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.